where is sine, cosine, and tangent, where are their inverses going to be a function? So in order for us to know if the inverse will be a function, that means the original function has to pass the horizontal line test. So let's start with the parent function y equals sine of x. So we know that sine of x starts at the origin. At pi over 2 it's at 1. And at pi it's back to the x-axis. Now if I connected those 3 points, would that pass the horizontal line test? No, so I cannot use all 3 of those points, but what if I get rid of that 3rd point? Right now, does it pass the horizontal line test? Yes. Now let's keep going back to the left to see if there's more of a function that would pass the horizontal line test. So at negative pi over 2, where's the y value? Negative 1. What about a negative pi? 0. Now, would that pass the horizontal line test? No. So what if I got rid of negative pi 0? Does it pass the horizontal line test? Yes. So those are the 3 points we are going to use for the horizontal line test. Now, it does need to be curved, so make sure it's curved. And these are called the functional values for the sine parent function. Make sure you write these down. And the boundaries that mark where the inverse would be functional would be from negative pi over 2 to positive pi over 2. And we have points at negative pi over 2 and positive pi over 2, so we'll use the square bracket for our integral notation. And you'll want to make sure that this integral is memorized. So you need to memorize this integral for sine. So sine is functional from negative pi over 2 to positive pi over 2 inclusive. Now sometimes this is referred to as principal value. You might want to make a note of that as well. So functional or principal. Okay, now we are going to plot the inverse based off of those 3 points, and I'm going to quickly just write a quick table of values. This first ordered pair is negative pi over 2. The y value is negative 1. The middle point is the origin, 0, 0. That last point is pi over 2. And the y value is 1. Now from ordered pairs, you can quickly find the inverse ordered pair by just reflecting the point, not reflecting the point, but just finding the inverse point. So flipping the points, negative pi over 2, negative 1, when I switch the order, that would be negative 1, negative pi over 2. So that inverse point would be negative 1, negative pi over 2, down in quadrant 3. 0, 0, when you reverse the ordered pair, it's still 0, 0. So we're just switching x and y. And that last point, pi over 2, 1, when you switch the ordered pair, it would be 1 pi over 2 in quadrant 1. And connect those 3 points. They are going to be curved. And looking at the inverse for sine, is it functional from those 3 points? Yes. Yes. So it's functional from negative pi over 2 to positive pi over 2. Okay, now we're going to do the same process for cosine as well as for tangent. So for cosine, cosine starts at 0, 1. At pi over 2, it's on the x-axis. At pi, it's at negative 1. And at connected these points, so far, does it pass the horizontal line test if I ignore this point down here? Yes, but what happens when I come back up to the x-axis? Does it pass the horizontal line test? No. So we don't need this point at 3 pi over 2. But let's check the left side of 0. That next point would be at negative pi over 2, 0. And if I connect these, would it pass the horizontal line test? No. So erase that point. And we can see that cosine, its functional values, are from 0 to pi inclusive. We have a point at 0, we have a point at pi. Again, these are called the functional values for cosine, or sometimes they're referred to as principal values. And again, this one also needs to be memorized. Now we need to graph the inverse. So in graphing the inverse, our first point is 0, 1. So when I invert that point, what would it be? 1, 0. The next point is pi over 2, 0. So when I invert that point, what would it be? 0 pi over 2. And pi negative 1, when I invert that point, it would be? Negative 1 pi. And those 3 points need to be connected, and it's going to be curved. And looking at that inverse is the inverse of function. Yes, we made it that way. And the last one that you'll have to memorize will be for good old tangent. Tangent has vertical asymptotes at negative pi over 2, positive pi over 2. The middle point is at the origin. Left arm is down, right arm is up. Does that graph pass the horizontal line test? Yes. So the entire graph for tangent is going to be functional. So for tangent, the functional values are going to be from negative pi over 2, which is where our left vertical asymptote is, to positive pi over 2, which is where our right vertical asymptote is. But can I have points at negative pi over 2 or positive pi over 2? No. So these need to have parentheses for that interval notation. And again, these are called the functional values for tangent, and that's one you also need to memorize. So sine and tangent are both negative pi over 2 and positive pi over 2, but sine includes negative pi over 2 and positive pi over 2, but tangent does not because it has asymptotes at those values. Then cosine is the oddball that goes from 0 to pi inclusive. Now graphing that inverse, let's see that leftmost point is negative pi over 4, negative 1. So what would the inverse point be? Negative 1, negative pi over 4, 0, 0, when you flip it around, it's still 0, 0. Pi over 4, 1. What would the inverse point be? 1 pi over 4. And those 3 points make up the inverse function, but instead of the arms going up and down, for the inverse, they go side to side. And instead of having vertical asymptotes, the inverse will have horizontal asymptotes at negative pi over 2 and positive pi over 2. And is that inverse a function?
Yes.
Yes. So make sure you memorize those three intervals. So sine and tangent are both negative pi over 2 to positive pi over 2. Sine is inclusive, tangent is not. Cosine is the oddball from 0 to pi, inclusive. Okay, now doing a little bit of math, and you'll have to know the unit circle. So the instructions say to solve for x, which is an angle from 0 degrees to 360 degrees, or in radians that would be from 0 to 2 pi. Now, for calculus, radians is preferred, so we're not even going to deal with the degree. We'll do radians only. So answers in radians. Okay, number one, we have cosine of angle x is equal to square root of 3 over 2. So we're looking for the angle whose cosine is square root of 3 over 2. And what would that reference angle be? It's pi over what? Pi over 6, which would be 30 degrees. So the cosine of 30 degrees is square root of 3 over 2. Now, the next thing we need to think about is our quadrant. So I know in quadrant 1, sine and cosine are both positive. In quadrant 2, sine is positive, cosine is negative. Quadrant 3, sine and cosine are both negative. And in quadrant 4, sine is negative, cosine is positive. So looking at this diagram, and noticing that cosine is positive, how many answers should I have? 2. Cosine is positive in quadrant 1 as well as in quadrant 4. So you need all possible answers from 0 to 2 pi. So we already have our first answer. X is equal to pi over 6. So 30 degrees has a cosine of square root of 3 over 2. But that also occurs down there in quadrant 4. And what would that angle be in quadrant 4? 330 degrees, and in radians, what would that be? 11 pi over 6. So pi over 6 and 11 pi over 6. Now this is how your answers will appear in the answer sheet tomorrow. We'll have all answers listed from least to greatest. So pi over 6 would be first, 11 pi over 6 would be second. Next one, number 2, the sine of angle x is equal to negative square root of 3 over 2. What would that reference angle be? Pi over 6? Wait, that's not right. Pi over 3. So this would be 60 degrees. So sine of 60 degrees is square root of 3 over 2. And so this would be x is equal to, now thinking about my quadrant, and which quadrant is sine negative? 3 and 4. So if my reference angle is pi over 3, what would that angle have to be in quadrant 3? 4 pi over 3. And what would that angle be in quadrant 4? 5 pi over 3. So 4 pi over 3 and 5 pi over 3. Okay, so number 3. So cosine to the negative 1 power means arc cosine, or cosine inverse. So cosine inverse of negative 1/2 is equal to x. Does that look like the format for number 1? No. So we're going to get the format looking more like problem number 1. So if I have cosine inverse, well, what's the inverse of cosine inverse? Cosine, right? Cosine inverse, its inverse would just be cosine. So to get rid of this cosine inverse, I'm going to take the cosine of both sides. So I'm going to cosine the left side, cosine the right side. So cosine of cosine inverse, those cancel each other out. So on the left side, I'm only left with a negative 1/2. On the right side, I'm left with cosine of x. Now does it look similar to problem number 1? Yeah. Once I took the cosine of both sides, yes. Now it looks like problem number 1. Now I'm going to figure out what angle has a cosine of negative 1/2. reference angle be? Pi over 3, which would be 60 degrees. But in which quadrant is cosine negative?
Second and third.
Yeah, quadrants 2 and 3. So what did you say that angle was in quadrant 2? 2 pi over 3. And in quadrant 3, that angle would be 4 pi over 3. Next one, we have arctan of 0 is equal to x. So if I want to get rid of arctan, well, what's the inverse of arctan? Tangent. So I can tangent both sides. So take the tangent of the left side, tangent of the right side. So tangent of arctangent, that cancels, and what's left on the left side? 0. We have this 0 left over, and on the right side, this is tangent of x. So now, we have to figure out what angle has a tangent of 0. So thinking about our unit circle, over here to the right, this point would be 1, 0. Up here at the top, this would be 0, 1. Over here on the left side, this would be negative 1, 0. And at the bottom, this would be 0, negative 1. So if tangent is sine over cosine, and we see that the tangent is equal to 0, that tells me the sine has to be equal to what? 0. So looking at all 4 of these, which of these angles have a sine of 0? 0, pi, and one more. 2 pi. So that one has 3 answers. So all possible answers from 0 to 2 pi need to be included. Next one, number 5. To get rid of arctan, I need to tangent both sides. So take the tangent of the left side, take the tangent of the right side. Tangent of arctangent, those cancel, and what's left on the left side? Square root of 3 over 3. And on the right side, we just have tangent of x. And what's our reference angle? What angle has a tangent of square root of 3 over 3? Pi over 6. And in which quadrant is tangent positive? First and third. So what would that angle be in quadrant 1? Pi over 6. And what would that angle be in quadrant 3? 7 pi over 6. Because pi is 6 pi over 6, so one more will get us to 7 pi over 6. And number 6, how can I get rid of arcsine? Take the sine of both sides. So sine the left side, sine the right side. So sine of arcsine, those cancel each other out. So what's left on the left side? Negative 1/2. And on the right side, we would have sine of x. What is our reference angle? What angle has a sine of 1/2? Pi over 6, which would be 30 degrees. We agree? So in which quadrant is sine negative? 3 and 4. So what would that angle be in quadrant 3? 7 pi over 6. And what would that angle be in quadrant 4? 11 pi over 6. So 7 pi over 6, 11 pi over 6. Next one, number 7, instead of cotangent, what can I change that to? Tangent. The tangent of x is equal to, this could be 0 over what? 1. What else could it be? 0 over negative 1. So I'll put a plus or minus 1. So if the cotangent is 0 over plus or minus 1, the tangent would be plus or minus 1 over 0. And when you divide that, that means the tangent has to be what? Undefined. So again, thinking about our unit circle, here's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And in order for the tangent to be undefined, we need to have a 0 in the denominator, and a tangent is sine over cosine. That means we need to find an angle whose cosine is 0. So looking at that diagram, what angles have a cosine of 0? Pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2. Number 8, how can I get rid of arcsecant? Take the secant of both sides. So take the secant of the left side, take the secant of the right side. So secant, arcsecant, those cancel. So that leaves us with what for the left side? 2, and on the right side would be secant of x. And to the secant, I could change that to cosine. And if secant is 2 over 1, the cosine would be 1/2. So for the reference angle, what angle has a cosine of 1/2? Pi over 3, 60 degrees. And in which quadrant is cosine positive?
1 and 4.
1 and 4, so we already have pi over 3. And in quadrant 4, what would that angle have to be? 5 pi over 3. And number 9, how can I get rid of arc cotangent? Take the cotangent of both sides. So cotangent of the left side, take the cotangent of the right side. Cotangent of arc cotangent does cancel, so that leaves us with negative 1 equals cotangent of x. Instead of cotangent, I can change that to tangent. And what would that reference angle be? Pi over 4. Sine and cosine are both square root of 2 over 2, and when you divide them, you get 1. But our tangent has to be negative. So in which quadrant is tangent negative? Yeah, 2 and 4 is right. So what would that angle have to be in quadrant 2? 3 pi over 4. And what about in quadrant 4? 7 pi over 4. So 3 pi over 4 and 7 pi over 4. Okay, this next section we're doing the same process, but now we're looking for what's called the principal value. And for the principal values, we're going to restrict ourselves. We're no longer going from 0 to 2 pi. If we're talking about tangent and sine, it needs to go from negative pi over 2 to positive pi over 2. And if we're talking about cosine, it needs to be between 0 and pi. Now, in this diagram, just go ahead and mark out the degrees, because for calculus, we don't really want to be dealing with degrees. Radians is preferred. So these are the functional values that we did on those first 3 graphs. We said sine was functional from negative pi over 2 to positive pi over 2 inclusive. Cosine is functional from 0 to pi inclusive. And there's a mistake with tangent. What's the mistake? Yeah. Tangent at negative pi over 2, there's a vertical asymptote. Can I have a point on a vertical asymptote? No, so these should not be equal to. So where we have asymptotes, they cannot equal. So both of those should just be a less than. So go ahead and correct that mistake on the list. Okay, number 10. We need to find the principal value. So we have arc cosine of 1/2. Now when we write our answer, if I'm dealing with cosine, my answer should only go from 0 to pi. So So should I have an answer of 3 pi over 2? No, because is that between 0 and pi? No. So if it's asking for the principal values, you have to use these restricted domains from our functional values. So principal, functional values, it's the same interval. Same thing. Okay, so first of all, I have to figure out what angle has a cosine of pi over 2. Not pi over 2, it's just a pi over 2. We need to figure out what angle has a cosine of what? 1/2. So what angle has a cosine of 1/2? Pi over 3, which is 60 degrees. Is pi over 3 between 0 and pi? Yes. Now, another answer we would have had on the previous section, what other quadrant is cosine positive?
4.
Quadrant 4. So our other answer previously would have been 5 pi over, not 6. It would have been 5 pi over 3. Now, is 5 pi over 3 between 0 and pi? No. So it's the same thing we've been doing, but it's going to be less answers. So your answer should be only the one that's from 0 to pi inclusive if you're talking about cosine. But if we're talking about sine, like in number 11, sine is functional from negative pi over 2 to positive pi over 2, inclusive. Now, what does that actually mean? Negative pi over 2 would be down here. Positive pi over 2 would be up here. So my angle has to be somewhere between 4 and 1 for my quadrant. But if the value is negative, which quadrant could it not be in? Yeah, it can't be in quadrant 1. In quadrant 1, sine is positive. So I need the angle that's in quadrant 4. What would the reference angle be? What angle has a sine of 1/2?
Pi over 6.
Yeah, 30 degrees, which is pi over 6. And what would that reference angle be down here in quadrant 4? So what would the angle be? What is it? 330 degrees, which would be?
11 pi over 6.
Okay, so you're saying 11 pi over 6. 11 pi over 6, you're saying falls like right in here? Is that between negative pi over 2 and positive pi over 2? Yes. Now, if it's right here, here's 0, and if I'm going this way, that angle would have to be negative, right? So it's not 11 pi over 6, it has to be what? Negative pi over 6. So you need to be certain that if you're talking about sine, your answer is between negative pi over 2 and positive pi over 2. So we can't use 11 pi over 6 because that's between 0 and 2 pi. So if it's down here in quadrant 4, that angle has to be a negative angle measure. Now tangent is going to be similar. Tangent is also functional from negative pi over 2 to positive pi over 2. So it has to be somewhere in this region right here. And if the tangent is positive, which quadrant could it not be in? 1. Which one could it not be in? 4. Quadrant 4 tangent is negative, so it can't be in quadrant 4. And what's the angle that has a tangent of square root of 3 over 3? Pi over 6. And is that answer between negative pi over 2 and positive pi over 2? Yes. Yes, so pi over 6 is the principal value. Number 13, again, if we're talking about tangent, it is functional from negative pi over 2 to positive pi over 2. And if the tangent is negative, which one could it not be? Can't be in quadrant 1 because tangent is positive. And what would the reference angle be? It would be pi over 6, but if it's down here in quadrant 4, it would have to be negative pi over 6. So it can't be 11 pi over 6 because it's not between negative pi over 2 and positive pi over 2. And number 14, instead of arc cosecant, let's change this to arc what? if I invert that fraction, this would be 3 over 2 square root of 3. That is not a unit circle value, so we'll need to rationalize that. So multiply numerator and denominator by square root of 3. So that gives us 3 square root of 3 over 6. And that simplifies down to square root of 3 over 2. So if I'm talking about sine, sine is functional from negative pi over 2 to positive pi over 2. And if it's positive, which quadrant can I mark out? Quadrant 4. And what's the reference angle? Pi over 3. 60 degrees. So sine of 60 degrees is square root of 3 over 2. And is that answer between negative pi over 2 and positive pi over 2? Yes. Yes. So pi over 3 is our principal value. Number 15. I want you to do number 15. Instead of arcsecant, I want you to change that to arc cosine. If arcsecant is 2, arc cosine would be 1/2. And if I'm talking about cosine, cosine is functional from what to what? 0 to pi. So I have to be up here in either quadrant 1 or 2. Which one can I mark out? Quadrant 2. In quadrant 2, cosine is negative, so it's not quadrant 2. It has to be in quadrant 1. And what angle has the cosine of 1/2? Pi over 3. 60 degrees. And is that between, so is pi over 3 between 0 and pi? Yes. Yes. As our principal value. Next one, we have inverse cotangent of negative square root of 3. I'm going to change this to tangent. So arctangent, if this is negative square root of 3, I'm going to put it over 1. So this would be 1 over negative square root of 3. I'm going to rationalize that, multiply numerator and denominator by square root of 3. So arctangent of square root of 3 over negative 3. Now if I'm talking about tangent, where is tangent functional? Negative pi over 2 to positive pi over 2. So which quadrant could I mark out? Quadrant 1, because tangent is positive in quadrant 1. And the reference angle would be pi over 6. But for quadrant 4, what would it have to be? Negative pi over 6. Negative pi over 6. And is that answer between negative pi over 2 and positive pi over 2? Yes. Now for the last of these, or for the rest of these, we need to just work with the innermost parentheses. So work with the innermost parentheses. So we need to do this thing right here. Arc cosine of 1/2. So the cosine out front, just drop it down. And for these, we need to use the principal value. So if you're trying to solve these and you're like, oh, well, there's 2 answers, use the principal value. So arc cosine of 1/2. What angle has the cosine of 1/2? Pi over 6. Is it pi over 6? It's pi over 6. Now, it's just a unit circle question. What's the cosine of pi over 3? The cosine of 60 degrees is 1/2. Cosine of pi over 3 is 1/2. Number 18. Or actually, there's a shortcut. What happens with cosine and inverse cosine? They cancel. So what's the answer? 1/2. Will they cancel here? No. No, this is signed, this one is not signed, so this one we do have to work it out. So drop down the sign, work with the innermost parentheses. Now again, we are only using the principal value. And cosine, where is cosine functional?
0 to pi.
0 to pi. But if it's negative, I know it's not going to be quadrant 1. It has to be in quadrant 2. And what would that angle have to be? What's the reference angle? Pi over 6. So in quadrant 2, it would be 5 pi over 6. And now that we're done with the principal value, now it's just a unit circle question. What is the sign of 5 pi over 6? 1/2. And these questions will be in the evaluate section on your assignment. So use the principal value, then it's just a unit circle question. Think we have one more? Yes. Okay, this one, work inside the parentheses first. So if we need to do arctangent first, so this cosine, just drop it down. Now tangent is functional from negative pi over 2 to positive pi over 2. Which quadrant could I mark out? Quadrant 1. And what would that angle be? Negative pi over 6. The reference angle is pi over 6. But if it's in quadrant 4, it has to be negative pi over 6. And then bring down the minus. Now I need to take care of arc cosine of 1/2. And cosine is functional from what to what? 0 to pi. Which quadrant can I mark out? Quadrant 2. And what is the angle? What angle has the cosine of 1/2? Pi over 3. Now, still working inside the parentheses, I need to subtract these fractions. In order to subtract two fractions, what do we have to have? Common denominator. What's the common denominator? 6. So the first one is good. Leave it as negative pi over 6. Instead of pi over 3, we need to change that to 2 pi over 6. And now that we have a common denominator, we can subtract those. So negative pi minus 2 pi gives us negative 3 pi. Keep the common denominator at 6. And that simplifies to negative pi over 2. Now it's just a unit circle question. Negative pi over 2 would be down here. And that ordered pair would be 0, negative 1. So what is the cosine of negative pi over 2? 0.